Dear teachers and students, good morning. My name is Zong Xuesen, and my paper topic is the Federated Parking Flow Prediction Method based on blockchain and IPFS. Next, I will introduce my research in 5 aspects: background, challenges, solution, experiments, conclusion. The first is background. Traditional parking flow prediction methods have the following 5 methods: ARIMA, KNN, SVR, LSTM, federated learning, and blockchain. The first 4 methods are concentrated data-to-train models. However, with the emphasis on user privacy and data security, this method has been difficult to achieve. Federated learning protects data privacy by keeping raw data on local devices, but it relies on central server to aggregate local models. Once the central server fails, the training of the model will be interrupted, causing a single point of failure. Blockchain stores and updates federated models instead of central servers to avoid single point failures in the decentralized manner. However, the above method doesn't consider the low train efficiency of the federal model. When the parking flow prediction model parameters are large, the model data directly on the chain storage will exceed blockchain storage space demand is too large. The model data storage and query is slow, resulting in longer model training time. In addition, federated learning method lack incentive to improve the enthusiasm of participants in the process of model training. Not all participants contribute data actively. If there was no feasible incentive mechanism, participants with high-quality data might not participate actively, and ultimately affect the performance of the federated model. This paper defines a federated parking flow prediction method based on blockchain and IPFS. This method constructs a parking flow prediction model based on LSTM networks, trains the parking flow prediction model under the federated learning framework to ensure the privacy of parking data, and use blockchain to replace the central server to aggregate the local model to realize decentralization under the federated learning framework to prevent single point fails. At the same time, based on the temporal resistance of blockchain, it further ensures the safety and model data. In addition, in order to improve the enthusiasm of the participants, a contribution reward incentive mechanism is designed to provide a visible reward allocation without citing a public validation site. While considering the data volume of each participant and the performance improvement of the federated model. The following is a parking flow prediction model based on LSTM network, which is divided into 2 layers of LSTM and a fully connected layer. The current parking flow is predicted by combining the previous parking flow data. the input dependence is set to 168. The hidden layer unit is set to 150 and 50, and the fully connected layer uses 150 demand data and input to calculate and generate one-dimensional parking flow data output. The overall framework of the method is mainly composed of local participants, blockchain network, and IPFS networks. Local participants are visibly visible for the train of local model. The trained local model is uploaded and stored in the IPFS network, and the return the local model hash is stored in the blockchain network by calling the participant node of the smart contract. In blockchain networks, local model parameters are aggregated through smart contract, and the aggregated global model are stored in IPFS network. The returned global model returned parameters are stored in the blockchain network and sent to local participants. Then the global model is obtained from IPFS network. Finally, update the local model to a global model for the next round of the model chain. The designed incentive mechanism is divided into parts. One part is to evaluate the contribution of each participant's data value, which is based on the ratio of the number of local train sites to the number of all participants. The other part evaluates the contribution of each participant to the model performance improvement and obtains the model performance improvement degree by comparing the performance of the sub-federated model and the main federated model. Finally, the data volume contribution and the model performance improvement contribution are integrated to obtain the total contribution of each participant. The experimental data are selected from the parking data collected from 3 real parking lots in Qingdao, Shandong Province, China from April to September 2020, and the specific information is shown in the Table 1. For example, parking lot 2 has 400 parking space with fully traffic between 640 and 800 on working days, and between 100 and 250 on rest days. In order to compare the performance of the federated parking flow prediction model, the method proposed is compared with the method based on STM centralized data train. Table 2 shows the root mean square errors of the above two methods on the three participants' packing test datasites. Through observation and comparison, the performance of the federated model is slightly lower than that of the model based on STM centralized data training, but it meets the security of data privacy and actual needs. To measure the efficiency of the model training, 15 tests were carried out in the same environment with the federated learning method based on blockchain. In each test, the federated learning model training set was 10 rounds, and each participant trained the local model for 40 rounds. The training time of a single model, the time required for uploading a single model, the query time of a single local model, the time required for uploading a single model, and the query time of a single model, and the total training time of the federal model are shown in Table 3. The results reflect the effectiveness of the proposed method. In addition to reflect the advantages of using IPFS, the model data size is extended by 2 to 4 times, as shown in Table 4. Among the model upload time of the federated learning method based on blockchain and IPFS is stable at 0.97, which doesn't change with the increase of model data size. The model upload time of the federated learning method based on the increase of model data size. The model upload time of the federated learning method based on blockchain increase with the increase of model size, which further reflects the improvement of the training efficiency of the model. The following figure shows the model accuracy of the three sub-federated models and the main federated models based on the incentive mechanism of the three participants on each participant validation site. It can be seen from the figure that participants 1 and 2 have made great contributions to the model performance of the main federated model, while participants 3 have hardly improved the model performance of the main federated model. In the experiment, by citing the contribution weight of data volume and the contribution weight of the model performance improvement as 0.4 and 0.6 respectively, the reward or location proportion of each participant is calculated as shown in the figure below. The remuneration distribution proportion of participant 1 is the largest, accounting for 47.55%, followed by participant 2, accounting for 36.79%, and the participant 3 is a smaller list, accounting for 15.66%. Here is a summary of my research. Firstly, we propose a federated packing floor prediction method based on blockchain and IPFS to improve the chain efficiency of the federated packing flow prediction model. In addition, we propose a contribution incentive mechanism to provide a reasonable incentive allocation and improve the enthusiasm of participants. The above is all I said. Thank you very much for listening.